Okay. Hello everyone and welcome back to the Data Vault series. This is going to be our first stream and this is going to be our first programming video in the series. Today we're going to be looking at, we'll just be introducing the whole, how we're going to be programming this application. We'll be creating the base application structure that will be used throughout the entire series. And then we will also be looking at our account features. So this will be the create account, login, and log out sequences here. So we'll just go ahead and hop right into it. I'll be explaining a few concepts as we go along. So the separation of certain aspects and functions of our application, we'll be using a certain framework, or not a framework, but a little bit of a pattern that I will explain in brief. But we'll just pull up my desktop now, and we're good now. So this is the main.c file, and just before I start, I will go ahead and say that I created a bunch of automation files. So typically, if you've been around the channel, you'll see that when we program in C, we don't use the IDE, we use Visual Studio Code in combination with GCC. But to kind of automate GCC, we create batch files that will do something on this order here. However, since we have a bigger project, it might be annoying to have to manually update these batch files. So what I did is I created two Python scripts to, one, keep our library files updated. So we're going to be taking library files from both our CMathematics library and a few of the YouTube challenges. So we'll have to use a copy command essentially to copy all of these files from their source folders into our into our application here. So we'll have a library or somewhat of an include directory, but they will be included in the build path as well. And then the second Python script will just be to generate our run files, which will generate two batch files, one for run and one for debug, which will essentially just take a manifest path, and it will input all the paths to our source files from this into the batch files there. Okay, so we'll go ahead and get started. I will just start in the source directory here. So as with the CMathematics project, we're going to have a test directory which has our main file, and then the source directory which will hold all of the actual code that we need to run the program. So the main file will essentially be the front end stuff, so where we input all of our commands, where we input all of our data, and then the source directory will essentially hold all the code that allows us to handle that. So for source here, we'll just start with our data vault.h file, and then also data vault.c file. Okay, there is some noise going on, and I hope it's not very audible. But let me just check on that just to see how loud the mic volume is. Okay, it might be background, but I hope this isn't bad. Okay. All good. So we are in data vault.h, and we'll start here just by doing our macros. So if not defined, data vault h, define data vault h, and then end diff at the end. And then in here we're going to have nothing, or we won't have any value or any macros yet, but we will be including them. So we'll start with our typedef struct, and then we'll have our structure, and then we will name this just dv_app. So this will just be the structure that holds our application variables. This is what you're going to need to actually pass around an application instance with you. And then from this, we will just have two methods: void dv init, which takes in a dv app pointer dv, and then a void dv kill, which also takes in a pointer to an app. So what we're going to be doing with our application here is we're going to kind of have an MVC pattern. And what I mean by MVC is model view controller. So the model, in essence, is just the data. It's the data that's stored in the RAM or in your files or whatever. The view is what's presented to the user, and then the controller is essentially all the business logic, everything that you send commands through. It's what actually modifies the model. And the purpose of this is to create a separation between the view and the model, so that even if you have different platforms, you just have to modify the view instead of the model as well. So what this pattern enforces is that the model and the view cannot interact. So if you create a command, or if you type in a command in the view, that view cannot call or cannot modify model data unless it passes that command through the controller. The controller stays constant for all instances of the application. It's just the view which can change. So it creates a nice separation that allows you to kind of delegate tasks to different locations if needed. I have no clue what's going on outside. Okay, so yeah, this is our structure here, and then we will initialize and kill the app and allocate and deallocate memory in these two files here. So in datavault.c, I will go ahead and say, just do our include datavault.h, and then I will paste in the two signatures, empty bodies for now, just because we don't have any values to free or kill. And then before we proceed, I'm just going to start by copying our library files. So the way you can do that is just by going, I will put this in a repository somewhere, the automation files in their own repository, but if you pull from the Data Vault repository, you will see that we have our two commands here, update run files and generate copy command. We'll do the generate copy command, which essentially calls the Python script. And in the generate copy command, you see that this now generated our copy files command in the batch, which essentially just takes all of these files. So we have dynamic array, AVL, string stream, B tree, CMathematics, arrays, more string stream, AES, the hashing algorithms, and then number IO. So a bunch of different functions, mainly from CMathematics, but it will copy all these files into their respective directories in the source directory. So all I have to call now is just copy files. Oops. And then it's going to ask me to say if the targets are directories, and they are going to be all directories because it has to create them. So if you go into our lib now, I'll actually just zoom in again. You'll see that we have our CMathematics stuff here, which has a bunch of the folders, the files that we need. And then it also has some data structure stuff from our challenges, which is awesome. Okay. So in datavault.h, what we're going to do is we're going to start by doing our account stuff. So we're first going to have a state for our our app to tell whether or not we're logged in. Now, we're going to be enforcing that we're going to be assuming that the view just won't. We're going to be trusting the view here to not modify our logged in thing value here. But I was thinking of maybe just creating a singleton instance of this class where we have one instance of the class and that's it. Like, you can't instantiate it. So this main instance here is it's not open to the public. But for now, I will just keep it as is, but we'll look at that in future videos. So we need a Boolean essentially to tell whether or not we're logged in. And Boolean we can find in our CMathematics header file. So if we go ahead and include, it's going to be in lib/cmathematics/cmathematics.h, and then the state will just be Boolean logged in. And then the two values that we're going to have, or sorry, the three values that we will have pertaining to our account are going to be the dataKey, the Aes Key Schedule, and the IV and hash and salt values. And you can see all this stuff if you just go through the README sequences. So you see how we generate the salts and the IVs. And then we also have a dataKey. We also have our dataKey, and then when we generate the Aes Key Schedule as well. So in here we will have an unsigned character dataKey. This will not be, this is kind of like a tutorial, but it's more of a project walkthrough. And then pragma once is Windows specific, I believe. So I'll be just, you can essentially replace that with these macros here. The if not defined, data vault, and then end if here. Because if this macro here is not defined, then we want to define everything between here and the end if block. So it will prevent duplicate definition. Okay, so we have our unsigned character dataKey, and this will be an array, and the length will be what we want for AES 256. And we will just define a macro here, the key length, so define dv keylen 32. That's just the key length for in bytes for an AES 256 key length. So dv keylen. And then we're also going to have our key schedule, because if you remember, we're going to be using this key so every time we need to decrypt and re-encrypt data. So if we just called AES encrypt, I'll just find it over here. So AES encrypt, it's going to be generating this key schedule every time, and that's a bit expensive. So what we want to do is just call AES encrypt with schedule, which I separated on my own time. But this you can pass in the key schedule that you have previously generated. So we'll have an unsigned character AES Key Schedule, and this will be a 3D array, because just watch the AES video if you want more details, but essentially it's going to be a 4x4 key for every round. So we have AES 256 NR plus 1, so that's just every round plus 1 because you need an extra one. And then it's a 4x4, so AES block side, I need to include AES. So just make sure to have this include in there. And then it's AES block side by AES block side. Okay. And then we also have our random values. So instead of storing, so if we look back at readme.md and preview it, we see that we have a lot of IVs and salts, and I was just thinking, why not just store the whole list in a little or why not just store all the strings in one string and then just have offsets stored as integers, just to keep one pointer and keep it all consolidated. So we're just kind of a singular unsigned character pointer random, which will just be a string. So now, with these three values, or these three variables, we can go into dataVault.c and see how we're going to initialize them in our init and kill functions. So for init, we need to initialize the state. So that'll be dv.loggedin is equal to false. And I also have to have a bunch of includes up here. So we'll need to include lib/cmathematics/cmathematics.h. And then also our standard includes, so include standard lib.h, include standard io.h, and then include string.h. So we set logged into false, and then we're going to clear our keys. So memset dv.dataKey as 0, and the size is dv keylen. and then we will have memset dv.aes key schedule, also set it to 0. And since we have a 3D array, it's just going to be stored linearly. So the size of that will just be AES 256 NR plus 1. So that's the first dimension here. And then we can just simplify these two dimensions to block length. So this times AES block len. And that's good there. And then we'll initialize our pointers. So dv.random is equal to null. And we're going to set this to null for now just because we don't want to actually read any memory into random until we either create an account or not, until we log in, and then we'll free it when we log out. And then for dv kill, what we're going to want to do is reset state. So dv.loggedIn is equal to false. And then we want to clear the keys. So you can actually just copy and paste the memset variables over there into clear keys. And then we want to initialize the pointers, or free pointers. So if dv.random, then we're going to free dv.random. Like so. Okay, so that is the first step that we're going to be taking in our in this stuff here. So we have our initialize and kill functions, and this is all we're going to need to actually do our login and log out, or our create account, login and log out functions. All right. You know what I did not do? You know what? I may have screwed up, but we're good because we can just continue on. So I have a file IO bunch of functions that I have a full array, a file containing a bunch of IO functions that we can use for files, and I forgot to copy that over. So I will need to do that very quickly, and this will once again be on the GitHub once this is committed, but it is already in the test branch if you guys want to take a look at the code. So I need to go over into my test, leave on main. It's just in source I have okay. Okay, so in the, let me go back there. So I just added these two new files here, file io.h and file io.c, and I can create a video explaining what these are, but it's essentially just simple file functions that allow us to kind of simplify the reading and writing, which makes things a lot easier when we just have to do simple commands instead of creating all the pointers and all. But so that is all we're going to need now to write the create account, login, and log out functions. So as I said before, we are going to have we're going to be implementing an MVC pattern, which means that the model, so our model is essentially held in the DV app. It's not entirely, but we will see how that kind of comes into play and how it will be essentially our model. But the source here will also have our controllers. So we're going to create a new folder called controller. And in this controller, we're just going to have our, not a new folder, new file dv controller.h, and then dv controller.c. And in dv controller.h, we're going to include dv datavault.h, sorry. And then we will do our macro, so if not defined, dv controller h, define dv controller h, and diff. And then in here, we will essentially just do our 3 functions. So we'll have our, and all these functions are going to return our an integer. What API am I using? I'm not really using an API. It's just the main library files that I'm using right now it's just been this little CMathematics library that we've been working on for a while. So we have a bunch of encryption functions in there, like AES, and then a bunch of hash functions. But there's nothing else that I downloaded from the internet. It's just all code that we've written in previous videos. Okay, so for our functions, we're going to be returning integers as just to return the status of the function. So we'll have integer dv create account, and this takes in a dv app pointer dv, and then unsigned character user password, and an integer n. So the password is just a string of characters, and then the n is the length. And then we also have our integer dv login, which takes in a dv app pointer, an unsigned character user password again, and another integer n, and then integer dv logout with dv app pointer dv. Okay. All right. So to standardize our integers that we return here, we're going to go back into datavault.h. I'm going to probably organize this a little better to adhere more to the Mvc pattern. But for now, we're just going to have macros defining the return code. So hashtag define dv success 0, define dv file does not exist 1, define dv invalid input 2, and then define dv logged out as 3. So these are the main ones that I've found so far. So success will just be good. File does not exist. This will be if we can't find the file. So for example, if you're trying to log in but you don't have any password files or data files, and then invalid input, meaning that you input something invalid. So say if n was 0, and then logged out means you're trying to do something that you can only do if you're logged in, but you're not. All right. So I'm going to go ahead and copy these functions over to dvcontroller.c. So paste them in there. And then for includes, we're going to include dvcontroller.h. Then we're going to include /datavault.h to have access to the dv app structure. And then we're going to have a bunch of includes from CMathematics. And I'm just going to do all the includes now, just so we don't forget them. So we'll include /lib/cmathematics/util/numio.h. And in CMathematics, numio just has a bunch of values, or a bunch of functions that just deal with numbers and strings and conversions. So I'm going to go ahead and copy and paste just the start of this string. So include /lib/cmathematics, just because that's where all these includes are going to be from. So cmathematics/data/encryption/aes.h, then cmathematics/data/hashing/sha.h, then include cmathematics/data/hashing/pvkdf.h, and then include cmathematics/lib/arrays.h. And then we also want to include /lib/util/file.io. So those two header and source files that I just copied and pasted in. And then we'll have our standard includes. So include standard lib.h, include standard io.h, and then include string.h. Alright, just like that. Alright, so for create account, we'll just essentially be following along with the little sequence that we looked at. So I will actually just pull that up on the side. Make it really, I mean, that might be a mistake, but yeah, that's fine. So we'll just go through it, and I will relate it to the sequences that we wrote. So first is input validation. So in the MVC pattern, all input validation happens in the controller. So we have if not n or not user password. So this is if either the pointer to the user password is invalid, is null, or n is 0, meaning you didn't input anything. We're just going to return dv invalid inputs. So that's the return code that we had as a macro. And then we're going to generate our salts and IVs. So we'll have an unsigned character pointer random is equal to new random bytes. And here it's just going to be 7 right shifted by 4. And this is just 7 times 16. I'll just go back to our... So for the salts and IVs, we have 7 of them, and they're each 16 bytes. So I'm just going to do 7 left shifted by 4. And then I will comment here init files, and that will be, or you know what, let me actually just write that function right now. But we're going to have a new header and source pair called persistence, so dv persistence.h, and I will focus on this later, but for now I'm just going to write the definition. So in dv persistence.h, we're simply just going to have int dv init files, and we'll pass in an unsigned character pointer random. So I will focus on this later on. But for initialize files, we're just going to, that function is essentially just going to create all the files that we need for an account. So dv init files, passing in a random. Alright, so now we're going to hash the user's password. So we'll generate the hash first. Because if we look back at OneNote, or I mean, I can actually just go to README here. To create the account, this is login, but for creating the account, we essentially have to generate our salts, and then we're going to process the user password. So we have to first generate the hash to allow a user to log in with that password so we can compare it to something. And then the data key will be randomized, and we will derive our encryption key for that. So we'll generate the hash first, so SHA-3 context, Is that not found for some reason? Oh, I didn't include SHA-3, that's why. So make sure to include lib/cmathematics/data/hashing/SHA-3.h. So SHA-3 context, pointer, hash context. I actually don't even need to include SHA-3 because we made SHA.h for that. Or you know what? Never mind. Let me just keep it there. So we'll do a SHA-3 context pointer hash context is equal to SHA-3 init context. And just call SHA init context, passing in the mode SHA-3 512 because we just want the most secure we can. Then we're going to update it, so SHA-3 or SHA update, pass in SHA-3 512 as the mode. The context will be hash context. The string will be user password, and then the length of that string will be n. And then we will have SHA update. And with salt, the purpose of salt in hashing is just that you can add some randomization so that if you have two of the same inputs somewhere and you pass them through the same hashing algorithm, they won't generate the same output. But that can only happen if you have a randomized string that you concatenate, which is just our salt. So SHA update, SHA-3 512, hash context, and we pass in the random plus, and this is going to be a little interesting, but the random string here is essentially, like I said, is a consolidated version of all of our salts and stuff. So we're going to have an offset for the user password, but I will take care of that later, and then the length will just be 16. So update with salt. And then unsigned character pointer hash. And then for the output, and then we just digest. So SHA digest, SHA-3 512, hash context, and then pass in a reference to hash. Okay. Now I probably should have organized this a little better, but we are in the persistence file. We're going to have, this will be in the controller file, sorry. So in our controller header file, we're going to need a way to organize this random string here. And we're going to do this using offsets. So we'll have, these will all be external constant unsigned integers. So extern const unsigned int, and this will be user password salt offset. And then we're just going to copy and paste this 7 times, or copy and paste it 6 times. And then we're going to modify the name every time. So the first one should be user password salt, then it should be KEK salt. Then dataKey IV offset. Then we have data IV. Then we have name ID IV. Then we have ID, IDX IV. Wow, that is loud outside. And then we have cat ID IV. So these are all the salts and IVs that we need. And once again, these are all described in the README file. So now these are going to act as our indices or our cursor values for the individual values. So in dvcontroller.c, since these are external values, we need to define them. So just remove the, you can remove the extern keywords there. And then we're essentially just going to increment each value by 16 every time. So the first one will be equal to 0. Oh, I switched my keyboard. So we'll do 0, then 16, then 32, then 48, then 64, then 80, then 96. And you know what, I'm actually just going to do this a little nicer. So 0x00, then 0x10, 0x20 just in hex values, so it's evident that we're incrementing by 16. So 0x30, 0x40, 0x50, and 0x60. This just makes it a little more clear on what we're counting with. And then this random value, so what we're concatenating as the user password salt is just random plus the user password salt offset. So we're gonna index into the random string using that offset, and that's our salt. So we digest it and we have the output in hash now. So we want to write this to the file. So we're going to use a file struct from the file IO header. So we'll call this pwd file, and then file open, pass in a reference to pwd file, pwdfp, and then the mode will be wb. Or we'll do an if statement here just to make sure that it works actually. Or this file path is also not defined. I will do that later, but for now we'll just say pwd.dv. And then we'll write here, so file write, or actually isn't there a, no, sorry, my mistake. So we will call file write, passing in a reference to pwd file. The buffer will just be the hash value, and then the length will just be SHA get ret len idx, and we pass in SHA-3 512. And then we do file close, pass in a reference to pwd file, and then on the else block we're going to return dv file dne for the file does not exist. And then we also want to free the hash. Alright, so that's our hashing the user password. Now we want to generate the data key, or take care of the data key. And we'll start by generating. So an unsigned character pointer data key is equal to new random bytes, dv key len, just because we need the key to be the specified length, as we put in the header file. And then we have our output value, so unsigned character pointer kek for key encryption key, and we're going to derive this key encryption key using the PBKDF algorithm. So PBKDF2 HMAC SHA, and we're going to pass in user password as the password. The password length is going to be n. Then our salt here will be random plus KEK salt offset. Then the length of that will just be 16. Then the number of iterations we'll just say is 10. The SHA mode is going to be SHA-512 string. The derived key length is going to be our DV key length because we're going to be using AES-256 again. And then the output will just be a reference to KEK. I think I messed this up. Ah, that's fun. I misspelled my macro in the PBKDF. I will have to fix that later on. Okay, so we generated our, we derived our key, or our encryption key. Now we need to actually encrypt the key. So unsigned character pointer encrypted data key. This will just be Aes encrypt. The input is going to be our data key. It's going to be length of 16. Then the input key will be the key encryption key. The input key length will be AES256. These now have to be our macros from the AES file because this is 256 in bits instead of 32 bytes. Then the mode will be AESCTR. And then our IV will be random plus dataKey IV offset, so the dataKey IV. And then the output will just be a reference to encrypted dataKey. So we encrypted the key, and now we can write that encrypted dataKey. Alright, so we're going to do our something similar to what we did with the random values. So this will just be our file struct, dk file, and if file open, passing a reference to dk file, the file path will be dk.dv, and then the mode will be wb for writing in binary. And if that succeeds, we're going to call file write, passing a reference to dk file. The content to write is encrypted data key, and then the length of that is going to be dv keylen, because CTR will encrypt something and it will output the same size of that, which is awesome. And then we close the file. So file, close, and passing a reference to dk file, and then otherwise return dv file dne. That's pretty much it. Now after this, we're gonna free a bunch of variables. So we will free the hash, or we actually freed the hash up here. So we just need to free the data key stuff. So free data key, free KEK, free encrypted data key, and then free random. And then we return DV success. Okay. Alright, so that's that. And I guess we can look at deviant files now, which is just our persistence here. So in dv persistence.h we have, we'll play around with this a little bit. So we just want to do our standard stuff. So we need to include, or sorry, if not defined, dv persistence, h define dv persistence, h, and then at the end we'll do our end if. And then we'll do our int dv init files, pass an unsigned character pointer random. Oh, we already had that, sorry. Alright, let's copy the signature over to dvpersistence.c. And then dvpersistence.c. We're going to include the header. And then also our standard includes, so standard lib.h, include standard io.h, and then include string.h. Alright, so for dv init files, we're just going to create most of the files, or create all the files. So we'll do file create, pass in, oh, did I not? I didn't include the file IO. Alright, yep, just make sure that you include /lib/util/fileio.h. And then I simplified a lot of these commands to just allow us to create files in one line. So file create, and we'll have our name id map.dv, file create id idx map .dv, file create category id map.dv. So these are the three data abstraction files that we are going to be using. And then we also have two other files, which will be the IV file. So write into IV file. So that's file struct IV file. Then file open, pass in reference to IV file, iv.dv, and then we're going to be writing in WB mode. And let me just write in file writes. The buffer will be random, and then the length is going to be 7 left shifted by 6, 4. And then file close that. And I seem to remember that we already did this in DV controller. No, we did not. Okay, so init files automatically writes this, the random string into the IV file, which is exactly what we want. Okay. And then we also have write data IV into the data.dv folder or file. And this is just a random string, but I mean, it honestly doesn't need to. We just need to write some sort of memory into this, just because the way our file works is that we're going to have our indices of data.dv be in blocks of 16, and that first block is going to be just some random string. The reason why is because we have our index blocks as everything else, or sorry, we're representing each block using indices, and we want to start that counting at 1. So the first block will just be nothing. Ooh, did not mean to do that. So we just need to write some random string. So we can just do file struct, data file, file open, pass in a reference to data file, data fp, or sorry, data.dv, and then writing in binary mode, and then file write into data file. The buffer will be random, and this can be, this could be a problem. I'm just going to do random and 16. It doesn't have to be, it just needs to be some sort of string. And then file close, and then a reference to data file. So this creates the last 5 files that we don't create, or that we don't create in create account. Otherwise, we're creating the password hash file, and then also the encrypted data key file here. So this create account function should now work. I've I definitely know I should have organized this a little better, but I didn't copy and paste in any testing stuff. But I will test this on my own, and I will later on, and then I will actually post the results, or I'll just put any fixes that need to happen in the comments section. Okay. So for the login and logout functions, we're going to need 2 extra functions in the persistence that we won't implement today. So that's going to be dvload, and this is going to take in an app pointer. So we need to include the /dataVault.h. So we need to pass in an app pointer, an integer dv kill. So these 2 functions, we don't need to define them right now, but they are going to be how we parse and stringify the memory from the 3 maps that we need according to the sequences that we wrote over here. So we have our load sequence, and then also, where is it? The save sequence. I don't know what's up here. Kind of overload. Yeah, that's fine. I'm not. Oh wait, this isn't kill. That should be dv save. Sorry. Yeah, not kill. So we will not put the definitions for those right now. Okay, so those are defined there, and then now in dv controller we can finally do our login and logout functions. So this is going to be some of the fun stuff here. Alright, so for dv login, I think we have this. Yeah, we already have the signatures pasted in. Alright, so for logging in, we're first going to initialize the app memory. So you just pass in the pointer. Then we need to read our salts and IVs from the random file. So we're going to have dv.random is equal to file read contents. That's another file IO function. This automatically allocates a string. So we're going to read in IVFP. Or sorry, iv.dv as a string. My mistake. And then we're going to hash the input and compare. So this is where we're actually going to be validating the password. So validate input password. So generate input hash. So we're going to do our SHA-3 context. Hash context is equal to SHA init context. Pass in SHA-3512 as our mode. And we do SHA update. Pass in SHA-3512. The context will be hash context. The value will be user password, and then we will pass the length is n. And then also we need to pass in the salt, because once again, the point of having a salt is that you can only create the same output if you have the identical input with the same salt as an output. You're not just comparing the inputs. When we actually generated the first hash and wrote it to the file, we had that salt. So this won't generate the same, or we won't get the same hash if we don't concatenate the salt. So here we're going to concatenate that. So SHA update, SHA-3512. The context is hash context. The input will be dv.random now, because that's where we read in the salt and IVs, plus the user password salt offset. And then n will be 16. and then we generate the hash. So SHA-digest, hash, the mode will be SHA-3512, the context will be hash context, and then the output will be reference to hash, and then we free the context, so SHA-free hash context. So now we are actually going to read the read expected value. So if, or we need to do our file struct, so file struct pwd file. So if file open, pass in a reference to pwd file, the path will just be pwd.dv, and the mode is RB because we're reading in binary. And if that does not succeed, we need to return dv file dne. And in my own time, I'm gonna clean up some of the memory here on my own and just find a way to do that cleanly, because we still have the hash, which is opened, or is open memory. Yeah. Okay. So here we're going to read a file. So character pointer expected is equal to file read. We're passing in a reference to pwd file, and then the number of bytes to read is SHA get ret len with SHA-3512. So get the return length of that, the specific cache algorithm we used. Then we're going to compare. So if memory compare, pass in the hash expected, and then the length is going to be SHA get ret len idx again. And the mode will be SHA-3512. So if that returns a value, then the compare did not return 0. So therefore, there was the two memories were not exactly the same. So dv kill the app, and then return dv invalid input. Otherwise, we succeeded. And found the same hash. So we're just going to clean up memory here. So file close, pwd file, and then we're going to free the hash and free the expected results. So in essence, what we're going to be doing here is almost exactly following the create account sequence, except we're not going to be writing anything to files. We're just reading expected results and then loading in memory. So we've done the password hash, so now we can generate our data key. So we need to derive the key encryption key. So unsigned character pointer KEK, and we're going to call the PBKDF algorithm again. The input password is user password, length is n, salt will be dv.random plus KEK salt offset, and that is length 16. Then the number of iterations is 10. I should make that a macro, and then the mode is going to be SHA-512 string. The reason why I'm not doing SHA-3512 is just because in some online tester that I was using, this was the only thing that they had, but maybe I can find it somewhere else and we'll figure it out. So SHA-512, the derived key length will be dv keylen, and then a reference to KEK as the output. So then we need to decrypt the data key instead of encrypting it. So we're going to have our file struct dk file, and if this opens, so if file open, pass in a reference to dk file, the path will be dk.dv, and then the mode will be reading binary. Let me just make sure these paths line up. Yep. So if that opens, then we're going to read. Otherwise we're going to free the key encryption key and then return dv file dne. If it does exist, however, we're going to decrypt it. So read, so character pointer encrypted data key is equal to file read, pass and reference to dk file, and dv keylen, and then file close. So we'll just close the password file. And then we want to decrypt. So we'll have a temporary string, and we're going to call the Aes Decrypt function. And this is one of the best parts of this application. We have created implemented so many of these algorithms, and now we're finally making use of them, which is awesome. This is a big test for all these algorithms too. When I was testing the stuff that I wrote on my own as reference, I was running into a few errors that I had to correct with the algorithms in the CMathematics library, which was good because we were testing corner cases and all that other stuff. But this application is going to be really fun and cool, or it's just going to be interesting to look at the results because it's taking in so much that we've done and giving us some sort of output for that, which is awesome. Alright, so we're going to decrypt the encrypted data key, and the input length will be dv keylen. The input key is going to be the key encryption key. The key length is going to be AES256. The mode will be AES-CTR. The IV will be dv.random plus data key IV offset, and then the output will be a reference to TMP. So if you look at the call to decrypt and then the call to encrypt, you will see that all the parameters are the exact same except for the inputs and the outputs, I guess, but that's trivial because we're outputting just to memory, so it doesn't really matter. But the input is going to be the encrypted value, and then for decrypt, the input is the encrypted value, and then the input value for the encrypt function is the decrypted value. But the parameters, the key length, the key encryption key, the AES mode, the AES length, the AES mode, and then the IV, these are all the same. It's just we're taking the inverse of the function, which have the same of all the other parameters. So we decrypt, and then we're going to copy in this temporary value. So memcopy. The destination will be dv.datakey. The source will be temp, and then the size will be dv keylen, and then we can free some values. So free temporary, free encrypted data key, and then free the key encryption key. Okay. And then we can generate our Aes Key Schedule to use all over. So that's a standalone function, which is awesome. Oh, hold on. I just kicked my charger. All right. Okay. So to generate this, we're going to call Aes generate key schedule. The input key is going to be dv.datakey. The mode is going to be AES256, and the subkeys will just be, the reference to that is going to be dv.Aes Key Schedule. Those are the proper parameters right there. And then now what we want to do is just call the load sequence. So dv load, passing in. Oh, I didn't include. Did I include persistence? Or is that just not defined? No, that is defined. I guess I just need to copy and paste the signatures over into dv persistence.c. Did it not work? So to call dv load, you just pass in the application pointer. There you go. Wait. Did I not include? Oh, wait. dv load. Hold on, there's a. Oh, I forgot a parenthesis. There we go. Does that work? It's not finding this for some reason. Even though I did not include persistence, that's why. Okay. Yeah, just make sure to include the persistence header file so that it knows what init files and load is. There we go. And load will take care of parsing or decrypting and parsing all of the map values that we need. And then after this we can update the state. So dv dot logged in is equal to true, and then return dv success. And I guess we can say here if dv or if not dv load, then we'll update the state. Or you know what, we have to do a little thing here, because if dv load doesn't work, then we need to return an error. So int res is equal to dv load, passing in dv, and if not res, then we want to update the state and return success. Otherwise we need to return an error. So else we need to we need to kill the app, so dv kill, pass in a reference to dv. Oop, nope, not that. I have no fucking clue what I just opened. Kill the app, and then return res. So res will be some value, some return code that we returned from load and save. Okay. And then logout is going to be super simple and super easy. We're just going to call dv save on dv, or we have to do a little bit of the error checking first. So int res is equal to that, and then if not res, or if res, then we need to return an error. So return res. And then otherwise we can just continue, so res is equal to, or we'll just kill the app now. So dv kill, and pass in dv. And as we saw in kill sets the logged into false. So we don't need to explicitly state that in the controller here. So dv kill, and then we just return dv success. And then we're logged out. Okay, so that is log in, log out, and create account. I need to organize how I'm putting out these videos a little more strategically. In the next video, I'm probably going to just be doing a pre-recorded video that will do a bit of a testing suite for the login and log out. So I will be introducing a new function that will allow us to print out strings, and then we'll kind of examine the results wherever they are, and just to see how we can actually verify the results and what we're producing, and how that's correct. And then we will also look at the file IO header file in another video, and then we'll also be maybe potentially taking a quick look at the Python scripts that I use to generate the commands. But yeah, for now, that's all I have for you guys. After we do all that, get rid of all that other intermediary stuff, we will then be looking at the parsing and stringifying this, so the load and save functions, and then we will actually be looking at the data functions, which will be awesome and cool. And yeah, so that's all I have for you guys today. Hope you guys enjoyed. I'm back from break, which is awesome, so I will hope to be putting out a few more videos relatively soon. So yep, I will see you guys next time. Have a good one.